Hello guys, welcome to our channel. So today we are going to continue with our pure maths revisions. So today we are having this question paper. This one is November 2022 session, pure maths paper 1. Okay, so I do believe guys that you have already done this paper before, so that you can make use of this session to assess yourself and to improve the way you can tackle pure maths question. Okay, so just make sure every time you open this question paper, you read these instructions to candidates. So in this question paper, we are required to answer all questions, and if a numerical answer cannot be given exactly, and the accuracy is required is not specified in the question, then in the case of an angle, it should be given correct to the nearest degree, and in other cases, it should be given correct to two significant figures. And this question paper carries a total of 120 marks. So let us move on to the first question of our question paper. Question number 1, which says expand 4 minus 3x raised to the power negative half up to and including the term in x cubed. And in the second part, we are also required to state the values of x for which the expansion is valid. Okay, so given that we are having this 4 minus 3x raised to the power negative half, and for us to expand this, we must express this 4 minus 3x in this form of 1 plus or minus x raised to the power n. Okay, so let us factor out f raised to this power negative half. So it is now 4 raised to the power negative half multiplied by 1 minus 3 over 4x raised to the power negative half. Okay, so 4 raised to the power negative half, it is equal to 1 over 4 raised to the power half, which is equal to the 1 over square root of 4, which is equal to 1 over 2. So this gives us 1 over 2 multiplied by 1 minus 3 over 4x raised to the power negative half. Okay, so what we are going to expand now, it is this 1 minus 3 over 4x raised to the power negative half. And for us to expand this, we are going to use our general formula for expansion of this these expressions of this form 1 plus x raised to the power n. So our expansion will be 1 plus xn plus n multiplied by n minus 1 multiplied by x squared divided by 2 factorial plus n multiplied by n minus 1 multiplied by n minus 2 x cubed divided by 3 factorial. And in this case, our n, it is negative half, our x, it is negative 3 over 4 x. So don't forget to include this sign for x. So now we can now say it is half multiplied by 1. Our n, it is equal to negative half multiplied by our x, negative 3 over 4x plus our n, it is equal to negative half multiplied by negative half minus 1 multiplied by negative 3 over 4x squared divided by 2 factorial. And we also have negative half multiplied by negative half minus 1 multiplied by negative half minus 2 minus 3 over 4x cubed divided by 3 factorial. Okay, so here we can now say it is half of 1, and let us multiply negative 0.5 multiplied by negative 0.75 negative 0.5 multiplied by negative 0.75. This gives us 3 over 8x. So let us simplify the second term, the third term, which says it's negative 0.5. It's negative 0.5 multiplied by negative 0.5 minus 1 multiplied by negative 3 over 4 squared divided by 2 factorial, which is simply equal to 2. And our answer, it is 27 divided by 128 x squared plus so here we are having 0.5, negative 0.5 multiplied by negative 0.5 minus 1 multiplied by negative 0.5 minus 2 multiplied by negative 3 over 4 raised to the power 3 divided by 3 factorial, it is 6. So we are dividing by 6. So our answer is 135 divided by 1024 x cubed. Okay, so let us simplify here by expanding this bracket. So to expand this, we are going to multiply each and every term by half. So this gives us half plus 3 over 8 multiplied by half. It gives us 3 over 16x, 3 over 16x, and also 27 over 128 multiplied by 0.5. This gives us 27 over 256 x squared plus 135 divided by 1024 multiplied by 0.5. This gives us 135 divided by 2048 x cubed. So this is our final answer for the first part of question number 1. So let us move on to the next part of our question, which says state the values of x. So we are required to state the values of x for which the expansion is valid. So what we have just expanded, it is 1 minus 3 over 4x. So our expansion to be valid, we are now saying the modulus of minus 3 over 4x, it is less than 1. Okay, we are only considering positive values. So it is now 3 over 4 multiplied by the modulus of x less than 1. So let us multiply both sides by 4 and divide by 3, and therefore we are now left with modulus of x being less than 4 over 3. So you can leave it as this, modulus of x is less than 4 over 3, or you can express it as x is less than 4 over 3, but x is greater than negative 4 over 3. Okay, so let us move on to question number 2, which says the functions h and g are defined by h of x is equal to x cubed and g of x it is equal to square root of x for x is greater than or equal to p, and we are required to state the least value of p for which g is defined. So given that g of x it is equal to square root of x, so for this function g of x to be defined, the value of x must be greater than or equal to 1, because we don't have a square root of a negative number. So the value of p is equal to 1. Okay, and let us move on to the next part of the question, which says find in the form x raised to the power n when n is rational, g of h and also g raised to the power 2 or g of g. So here we are given that h of x is equal to x cubed and g of x is equal to square root of x. So for us to calculate g of h, we are going to substitute this function h into this function g of x. Okay, so we can now say our g of x it is our h of x it is equal to x cubed and our g of x it is equal to square root of x. So our g of h it is square root of x raised to the power 3, and we know that square root of a it is equal to a raised to the power half, and if we are having a raised to the power b and it is also raised to the power c, our answer will be a raised to the power bc. So we are simply multiplying these powers b and c. So we are going to use this idea to simplify square root of x cubed. So it is now x raised to the power 3 raised to the power 2. So we are going to multiply 3 by half. So this gives us x raised to the power 3 over 2. Okay, so this one it is for g of h. Okay, and let us move on to the next part of our question, which says calculate for g raised to the power 2. So g raised to the power 2 it is simply equal to g of g. So we are going to substitute the function g of x into for x for the function g of x. So given that our g of x it is equal to square root of x, we are now saying g of g it is square root of x raised to the power half, because you understand that square root of x it is equal to x raised to the power half. So we can now say it is x raised to the power half raised to the power half again. So we are going to multiply these powers, and half by half it gives us 1 over 4. So our g of g it is equal to 1 over 4, x raised to the power 1 over 4. Okay, And let us move on to question number 3, which says a curve C is defined by the parametric equations. So we are having these parametric equations: x is equal to 3 plus 4 cosine theta, and y is equal to 1 plus 4 sine theta. So we are required to show that the equation of C represents the circle. So if we are having these parametric equations, x is equal to 3 plus 4 cosine theta, so I can label this equation number 1, and we are also having y is equal to 1 plus 4 sine theta. This one here is equation number 2. So we want to show that the equation of C represents the equation of the circle. So we are going to use our identity, which says sine squared theta plus cosine squared theta is equal to 1. Okay, so here we can simply make cosine theta on the first equation the subject, and then square everything. And we are also going to make sine theta on the second equation the subject, and then square everything. So let us start with the first equation. So for us to make cosine theta the subject, we are going to subtract 3 both sides. So we are now having x minus 3 being equal to 4 cosine theta, and let us divide both sides by 4. So it is now 1 over 4 x minus 3 being equal to cosine theta. Okay, let us subtract negative 1. So it is now y minus 1 being equal to 4 sine theta. Okay, so here we can also divide both sides by 4 to say it is now 1 over 4 y minus 1 being equal to sine theta. So here we can now square both sides for the first equation. So if we square both sides, we are going to get cosine squared theta being equal to 1 over 4 x minus 3 squared. Okay, so this gives us, if we square 1 over 4, it gives us 1 over 16 factor of x minus 3 squared. So this is equal to cosine squared theta. Okay, and let us square for the second equation. If we square both sides, we are going to get sine squared theta being equal to 1 over 4 a factor of y minus 1 squared. So this gives us a square of 1 over 4. It is 1 over 16 a factor of y minus 1 squared being equal to sine squared theta. Okay, so here we are now having cosine squared theta, and we are also having sine squared theta. So we can simply use our identity here to say if cosine squared theta is equal to 1 over 16 a factor of x minus 3, and our sine squared theta is equal to 1 over 16 a factor of y minus 1 squared. We can now add these two values to say it is now 1 over 16 x minus 3 squared plus 1 over 16 a factor of y minus 1 squared, and it is equal to 1. Okay, and as you can see here, we are having 1 over 16 as our common factor. So we can simply factor it out to say it is now 1 over 16 a factor of x minus 3 squared plus y minus 1 squared being equal to 1. And let us multiply both sides by 16 to say it is now x minus 3 squared plus y minus 1 squared being equal to 16. And we know from our general equation of a circle that the general equation of a circle says that x minus a squared plus y minus b squared is equal to r squared, where a, b is our center, and r squared, it is the radius squared. So we can simply deduce our center from this equation, x minus 3 squared y minus 1 squared being equal to 16. So our center, it is now 3 1, and our radius, it is the square root of 16, because this is equal to r squared. So our radius, it is equal to square root of 16, which gives us 4. So our radius, it is equal to 4. And we are done with number 3. So let us move on to question number 4, which says the diagram below shows the graph of y being equal to f of x. So we are having this f of x we are having this f of x, which is equal to ln x plus 1. So we are required to sketch on separate diagrams the graphs of y is equal to modulus of f of x, y is equal to f of x minus 2, y is equal to 1 minus f of x. Okay, so let us start with this one of y is equal to modulus of f of x. So to sketch this graph, we are going to reflect this part of the graph that is below the x-axis in the y-axis with this x-axis as the mirror line. Okay, so for us to reflect this, we are going to draw something like this. So our graph will be like this, starting from the origin, following this asymptote. Okay, so right, we draw it like this. Okay, so this one, it is for y being equal to modulus of f of x. Okay, and let us move on to the next question, which says sketch the graph of y is equal to f of x minus 2. So here we are having a transformation, so it is a translation by 2 units in the positive direction of x-axis, because we are having a negative here. But if we are having a positive, it will be a translation by 2 units in the negative direction of x-axis. So for us to sketch this graph, we are going to add 2 units to every x coordinate on this graph of f of x. So given that our graph is passing through the origin, so at origin we are having a point 0, 0, so we are going to add 2, so meaning to say our graph, it is now intercepting this x-axis at x is equal to 2, and we are also required to translate this asymptote from -1 by 2 units in the positive direction of x-axis. So given that our asymptote, it is at -1, and if we translate it by 2 units in the positive direction of x-axis, it will be at this point 1. So here it is now our asymptote passing through this point 1, and our x-intercept, it is now at 2. So our graph will be like this. Okay, so this is the graph of y being equal to f of x minus 2. Okay, and let us move on to the last part of our question, number 4, which says y is equal to 1 minus f of x. So here we're having 2 transformations. The first one, it is a reflection in the y-axis with the x-axis as the mirror line, and the other one, it is a translation by 1 unit in the positive direction of y-axis. So given that our original function f of x, it is this graph in black, so this graph is passing through the origin, and if we reflect this graph, we are going to multiply every y coordinate with -1. So this part of the graph that is above the x-axis will be below the x-axis, and this part of the graph that is below the x-axis will be above the x-axis. So our graph will be like this, passing through the origin like this. So this one, it is for y being equal to negative of f of x, showing the reflection in the y-axis. Okay, and another transformation, it is a 1 unit translation by 1 unit in the positive direction of y-axis. So given that our graph, it is intercepting this y-axis at 0, 0, so to translate, we are going to move our graph with 1 unit upwards. So given that this is 0, so if we translate by 1 unit, our graph, it is now intercepting this y-axis at this point 1. So we can now say our graph will be like this, passing through this point, like this, passing through this point like this. Okay, so this is for y being equal to 1 minus f of x. Okay, and we are done. And let us move on to the next question, question number 5. So this one, it is a linear law question, and it requires a graph, so we can skip this one. And let us move on to question number 6, which says find the particular solution of a differential equation x plus 1 squared dy by dx plus 2 being equal to 0, given that y is equal to 1 when x is equal to 0, and we are also required to express y solely in terms of x. Okay, so the first thing we need to do here is to shift this positive 2 to the other side of the equation, and it becomes negative, and then divide both sides by x plus 1 squared, so that we are going to be left with the dy by dx term on the left hand side being equal to negative 2 over x plus 1 squared, and then integrate both sides, and then we can find our particular solution and then express y in terms of x. So given that our differential equation is x plus 1 squared dy by dx plus 2 being equal to 0, and if we shift this 2 to the right hand side of the equation, it becomes negative. So it is now x plus 1 squared dy by dx being equal to negative 2, and let us divide both sides by x plus 1 squared. So we are going to be left with the dy by dx on the left hand side of the equation being equal to negative 2 over x plus 1 squared, and we can also express 1 over x plus 1 squared as x plus 1 raised to the power negative 2. So here we can now simply separate our variables to say it is now dy being equal to negative 2 x minus x plus 1 raised to the power negative 2 dx. Let us integrate both sides. So now it is the integral of dy being equal to minus 2, the integral of x plus 1 raised to the power negative 2 with respect to x. So on the right hand side, we are going to use our general formula for integrating functions like this of x plus 1. So if we are integrating x plus 1 raised to the power n with respect to x, our answer will be x plus 1 raised to the power n plus 1 divided by n plus 1 plus our constant c. So here we can now say it is y being equal to negative 2 multiplied by x plus 1 raised to the power minus 2 plus 1, it gives us negative 1 divided by negative 1 plus c. Okay, so negative 2 divided by negative 1, it gives us 2. Therefore it is y being equal to 2 a factor of x plus 1 raised to the power negative 1 plus c. And we are also given that y is equal to 1 when x is equal to 0. So we are going to use this information for us to calculate the value of c. So given that y is equal to 1, we can now say 1 it is equal to 2, and 0 plus 1 it gives us 1 raised to the power negative 1, which is simply equal to 1 plus c. Therefore c it is equal to negative 1. So we can now say it is now y being equal to 2 over x plus 1 minus 1. So this is our particular solution expressing y solely in terms of x. Okay, and let us move on to the next part of the question, part B, which says hence or otherwise sketch the curve represented by the particular solution of the differential equation in A above. So our particular solution, it is y being equal to 2 over x plus 1 minus 1. So here we are having a transformation of the graph of y being equal to 1 over x. So we are transforming this graph of 1 over x with this transformation. So we are having 3 transformations. The first one, it is a translation by 1 unit in the negative direction of x-axis, because we are having this positive here. And the other one, it is translation by 1 unit in the negative direction of y-axis, represented by this negative 1. And the last one, the last transformation, it is one-way stretch by 2 units in the parallel to y-axis. So our stretch vector here, it is 2. Okay, so to sketch this graph, we are going to start by sketching the graph of 1 over x, and then start to transform the graph of 1 over x using these transformations. So let us sketch the graph of y being equal to 1 over x. So this is our graph. Is this y-axis and this x-axis. So the graph of 1 over x, this y-axis is our asymptote, and also x-axis, it is also asymptote. So our graph will be like this. Okay, so x is equal to 0 is asymptote, and also y is equal to 0 is our asymptote. So let us start by transforming this graph by 1 unit in the negative direction of x-axis, meaning to say this asymptote at x is equal to 0, or the y-axis, will be translated by 1 unit in the negative direction of x-axis. So it will be like this. So our new asymptote will be at this. This one, it is our y-axis. This one, it is also our x-axis. And let us also transform our graph by 1 unit in the negative direction of y-axis, meaning to say this asymptote of y is equal to 0, or the x-axis, will be translated by 1 unit in the negative direction of y-axis, meaning to say our asymptote will be at this point, -1. Okay, so for us to sketch our graph, we can now say it is a graph of, so we are having this y-axis, this x-axis, our asymptote at x is equal to -1, our second asymptote at y is equal to -1, and you can simply sketch this one, which is below this y-axis. And for us to sketch another part of our graph, we are required to find the value of the intercept, because it is now clear that our graph, it is intercepting this y-axis and this x-axis, because these axes are no longer our asymptotes. Okay, so the graph intercepts with the y-axis when x is equal to 0. So from this equation, y is equal to 2 over x plus 1 minus 1, we can simply make x 0 to say y, it is now equal to 2 over 1 minus 1, therefore y is equal to 1. So our graph, it is intercepting this y-axis when y is equal to 1, and let us find the x-intercept. So the x-intercept occurs when y is equal to 0. So it is now 0 being equal to 2 over x plus 1 minus 1, and let us shift this -1 to the other side of the equation, and it becomes positive. So it is now 1 being equal to 2 over x plus 1, and we can multiply both sides by x plus 1. So it is now x plus 1 being equal to 2, therefore x is equal to 1 again. So our graph, it is intercepting in this x-axis when x is equal to 1. So our graph will be like this, intercepting this y-axis, this point, like this. So we are done with the question number 6, and let us move on to the next question. Question number 7, which says a cooperative sells chickens and dozens of eggs. The total daily taking C partly varies as the number of chickens sold N, and partly varies as the number of dozens of eggs D sold. So we are required to write an expression for C in terms of N, G, and the constants H and K. Okay, so given that we are told that the total daily takings C, it partly varies as the number of chickens sold N, and it partly varies as the number of dozens of eggs D sold. So we can now say C, it is equal to K N plus HD. Okay, so this is our expression for C in terms of N, D, and the constants H and K. And let us move on to the next question. The next part of the question, which says a total of 120 was collected when 15 chickens and 15 dozens of eggs were sold, and a total of $90 was collected when 10 chickens and 20 dozens of eggs were also sold. So we are required to find the value of H and the value of K given this information. So we can now say it is 120. So our total daily takings, it is 120 when we have sold 15 chickens, so it is now 15K plus 15 dozens of eggs, so it is 15H, and this one becomes our first equation. And we are also told that our total daily takings, it is $90 when we have sold 10 chickens, so it is 10k, and 20 dozens of eggs, so it is also 20h, and this becomes our second equation. So here we are now having a simultaneous equations, and for us to calculate for the value of k and the value of h, we are going to use it's either method of elimination or the method of substitution. Okay, so in this case we can simply use the method of substitution, because if we multiply the first equation by 2, we are going to get 30k, and if we also multiply the second equation by 3, we are going to get 30k. So we can simply subtract the first equation from the second equation and we can eliminate k. So let us multiply the first equation by 2 and the second equation by 3 to say it is now 120 by 2, which is equal to 240, being equal to 30k plus 30h. And if we multiply 90 by 3, it gives us 270, being equal to 30k plus 60h. And let us subtract these two equations to say it is now 240 minus 270, which is equal to minus 30, being equal to 30 minus 60, which gives us minus 30h. So h, it is equal to 1. And let us move on to calculate the value of k. Given that h is equal to 1, so we can simply substitute the value of h in the second equation to say it is now 90, being equal to 10k plus 20 multiplied by 1, which is equal to 20. Therefore 10k, it is equal to 90 minus 20, so 10k, it is equal to 70. Therefore k, it is equal to 7. So h is equal to 1 and k, it is equal to 7. And let us move on to the next part of our question. Part C, we say state what the values of h and k represent in this situation. So the value of h, it represents the unit price of 1 dozens of eggs, and the value of k represents unit price of 1 chicken. So this is what is meant by these values of k and h. Okay, and let us move on to the last part of our question, number 7, which says find the total daily takings if 20 chickens and 30 dozens of eggs were sold. So given that we are having this expression, c is equal to kn plus hd, and our k, it is equal to 7 and our h is equal to d. So our expression here is now c being equal to 7n plus d, and we want to find the value of the total daily takings if 20 chickens and 30 dozens of eggs were sold. So c, it is equal to 7 multiplied by n, the number of chickens sold, so it is 20, plus d, the total dozens of eggs sold, so it is 30. So c, it is equal to 7 multiplied by 20, which gives us 140 plus 30. So c, it is equal to $170. Okay, and let us move on to question number 8, which says prove by mathematical induction that the sum of 8r minus 1, it is equal to 4n squared plus 3n. For n, it is an element of natural numbers. Okay, so here we are having the sum of 8r minus 1 and n here from r is equal to 1, being equal to 4n squared plus 3n. For n, it is an element of natural numbers. So the first step is to say for n is equal to -1, and we can test this on the left hand side of the equation. So it is on the left hand side, for n is equal to 1, it is now 8 multiplied by 1 minus 1, which gives us 7. And for n is equal to 1, on the right hand side, it will be 4 multiplied by 1 squared plus 3 multiplied by 1, and this gives us 4 plus 3, which is equal to 7. So the left hand side, it is equal to right hand side, Therefore, the statement it is true for n is equal to 1. Okay, and let us move on to the assumption state. Assuming that for n is equal to k, so for n is equal to k, we can now say it is k here from r is equal to 1, 8r minus 1, it is equal to 4k squared plus 3k. Okay, and let us move on. For n, it is equal to k plus 1. So if we are having n is equal to k plus 1, you can simply put k plus 1 here. From r is equal to 1, and we are having 8r minus 1 being equal to 4k plus 1 squared plus 3k plus 1. Okay, and the last stage of our calculation, it is the proof stage. So we want to prove that if we are having k plus 1 here, from r is equal to 1, hr minus 1, and this is equal to r minus 1, 8r minus 1 plus the k plus 1th term. So the k plus 1th term, we are going to substitute k plus 1 for r in this summation here to say it is 8 multiplied by k plus 1 minus 1. So we are going to prove that this terms here on the right hand side of the equation, it is equal to this expression here, 4 plus k plus 1 squared plus 3 plus k plus 1. Okay, so given that this summation here from r is equal to 1 up to k, it is this one here for 4k squared plus 3k. So we can now say it is 4k squared plus 3k plus 8k plus 1 minus 1. So it is now 4k squared plus 3k plus 8k plus 8 minus 1, and this gives us 4k squared plus 3k plus 8k plus 7. Okay, so we want to show that 4k squared plus 3k plus 8k plus 7 can be expressed in this form: 4 a factor of k plus 1 squared plus 3 a factor of k plus 1. So to show this, we are going to adjust our 7 to say we can write 7 as 3 plus 4. So if we write 7 as 3 plus 4, it is now 4k squared plus 3, not plus 3, we can put 8k plus 4 plus 3k plus 3, because we know that if this 4 here plus this 3 here, it gives us 7 here. Okay, so from this 4k squared to this 4 here, we can factor out 4 because 4, it is a common factor. So it is now 4 a factor of k squared plus 8k plus 1 plus here we can also factor out 3 because it is a common factor. So it is 3k plus 1. So we have managed to obtain this 3 a factor of k plus 1, meaning to say we are on the right tracks. So let us try to factorize this k squared plus 8. It's not 8k, but it's 2. It is 4k. It is 2k. Okay, so let us factorize this k squared plus 2k plus 1. So to factorize this, we are looking for two numbers that if we multiply these two numbers, we are going to get k squared, and if we add these two numbers, we are going to get 2k. So these two numbers are k and k, so it is now k squared plus k plus 1, and we can factor out k for these two numbers, k squared plus k, so it is now k a factor of k plus 1, and we can also factor out 1, and it is k plus 1 here, and k plus 1, it is our new common factor, so we can factor it out to say it is now k plus 1, a factor of k plus 1 again. So this is equal to k plus 1 squared. Okay, so our answer, it is 4 a factor of k plus 1 squared plus 3 k plus 1 is required by our question. So here you can now say the statement is true for n is equal to 1, n is equal to k, n is equal to k, k plus 1. Okay, and we are done with our question number 7, and let us move on to number 9 of our question paper, which says express 2 over 4 r squared minus 1 in partial fraction. So here we can wrap this. So here we are having 2 over 4 r squared minus 1. And the first step here is to factorize this denominator to say it is now 2 over, here we are having a difference of 2 squares, because 4r squared it is a square and 1 it is also a square. So it is now 2r minus 1, a factor of 2r plus 1. And it is equal to a over 2r minus 1 plus b over 2r plus 1. Okay, therefore if we multiply both sides by 2r minus 1 multiplied by 2r plus 1, we are going to be left with the 2 on the left hand side of the equation being equal to a multiplied by 2r plus 1 plus b multiplied by 2r minus 1. And we can let r be equal to negative half. So if r is equal to negative half, we can eliminate this a. So we are going to be left with the 2 being equal to 2 multiplied by negative half. It gives us negative 1 minus 1, which is equal to minus 2b. Therefore b it is equal to negative 1. Okay, and if we also let our r be half, and if we multiply this 2 by half, it gives us 1, and 1 plus 1 it is equal to 2. Therefore 2 it is equal to 2a, and a it is equal to 1. So our answer in partial fraction it is 1 over 2r minus 1 minus 1 over 2r plus 1. Okay.